Assalamualaikum. Hi. Today we're going to continue with chapter 9 on estimation for software projects. What will be covered in this topic? We're going to start with some introduction on software project planning, and then we're going to look into what is estimation. Then we continue it with estimation techniques. After that, we're going to look into some decomposition techniques. After that, we will cover process-based estimation, and finally we're going to look into other types of estimation. So what is the goal of software project planning? So it's actually to establish a strategy for controlling, tracking and monitoring a project. So what is the aim of this software project planning? In the end, we want the project to be completed on time and achieve quality. So the next slide is on task set. So project planning task set, including first one, establish project scope. So when we start with the project planning, we need to identify what are the features to be delivered and what are the constraints of the system. So this can be defined by using narrative description, or we can use a set of use cases to determine those features and the constraints. Here we need to understand what are the customer needs, what is the business context, what is the project boundaries, that means what will be covered and what should not be covered. Next is on what is the motivation of customers towards the system, and is there any likely path that need to be changed. And even when you understand everything, nothing is still guaranteed. So the next step is to determine feasibility. Within the scope of the project that we have identified, will we be able to develop the software to meet this scope? The next step is analyze risk. So this is covered in chapter 35. Okay, and next one is to define the required resources. Okay, how many human resources that we need? What if there is any reusable software resources? Okay, and what are the environmental resources that we need? So when we identify the resources, we need to define the description of the resources, the availability of the resources, the time when the resources will be required, and the duration of the time the resources will be applied in the project. Next one is to estimate the cost and effort. So in order for us to determine the cost and effort estimation, the problems need to be decomposed. By having decomposed problems, we can further identify in terms of the size of function points, which we will look later on, the process task or use cases, and then we can reconcile the estimates. So after we have done with the estimation, then we can use that information to develop a project schedule. So the project scheduling will be covered further in chapter 34, but mainly it will establish a meaningful task set, define a task network, that means the relationship between those tasks, and then use scheduling tools to develop a timeline chart, and also identify any tracking mechanism to later on control and monitor the progress of the development. So project scope can help us to further define the software project plan. That means in terms of estimation, the cost and the effort and the time and the risk, maybe in terms of the project risk or technical risk or business risk, and the schedule in terms of the distribution of tasks in the development process, and also what is the control mechanism that can be used to track the progress. This will be input to our project plan. Next is on estimation. So before the project begins, software team should estimate what are the work to be done and how much resources that are required and what is the duration that you need the resources to be until the completion of the project. Then only we can do scheduling based on this estimation. So now let's look into estimation techniques. So in order for us to identify or use estimation process, we need to identify what are the estimation techniques that we can adopt. Okay, so these estimation techniques might be based on past or similar project experience, or conventional estimation techniques where you break down the task and the effort that is estimated based on the task, or the size, for example, function point estimation. And it can also be using empirical models or automated tools. So what we consider as reliable and accurate cost and effort estimation? How do we get a reliable and accurate cost effort estimation? One of it is to delay until the project is completed, which is not efficient because we need this estimation for scheduling. So when we do scheduling, that means it's in the early phase of software development, which is in the planning phase. So if we want to delay until the project is completed, there is no point to do estimation. But this is the only way that you get accurate cost and effort estimation. The second one is based on estimation on similar projects. Okay, unless you are working on similar projects, you can have this historical data. But if you are not working in a similar projects, then you will be basis on the existing project only. The third one is reliable decomposition techniques. In order for you to break it down into smaller parts, then you need to use proper decomposition technique. Okay, finally, use one or more estimation techniques. It is not educate to just rely on one estimation techniques. Next topic is on decomposition. Okay, when we talk about decomposition, we need to understand first about the accuracy of our estimation. So the accuracy of the estimation is depending on, the first one is the size of the product. Okay, so if we don't get the reliable estimation for the size, because everything else will be depending on the size, then whatever you estimate might not be reflective of the project that you're going to develop. The second one is the ability to translate the size estimate into human effort, calendar time, and money. Okay, based on the size estimation, again, you will realize or when you observe that all these other estimation relies on the size. Okay, then the third one, the degree to which the project plan reflects the abilities of the software team, whether the software team will be able to execute the task that has been distributed to them. And finally, the stability of the product requirements and the environment that supports the software engineering effort. So when we talk about decomposition, okay, if we talk about functional decomposition, we have from the statement of scope, we have the functions, then we further break it down into smaller sub-functions. So this is what we call as functional decomposition. In general, decomposition can be viewed from two perspectives, either from problem-based estimation or process-based estimation. So the functional decomposition is actually in the problem-based estimation, because from the problem we further identify all the functions and features, and we further break it down into smaller function. Okay, so next one is to identify the software size. So project estimation depends on accurate estimation of software size. So we can either compute software size based on direct or indirect. If we are talking about direct, that means we can use line of code. That means you have the code, the number of lines of the code. Or indirectly, we can use function points that use some kind of estimation using some information of the problem that is going to be solved. Okay, so in order for us to do this, we need to use historical data for the estimation. Okay, so line of code and function point are used as size estimation. And this size estimation is the basis for any cost and effort projections. So these measurements should be calculated based on project domain that is grouped by team size, the domain, the complexity, or any relevant parameters. So to be specific, we can use this 3-point or expected value. So we can calculate the expected value for the estimation, say S for size, can be computed as the weighted average of the optimistic. So we have the size for optimistic, and then we have the most likely, which is multiplied by 4, and then we plus the size for the pessimistic estimates. So we calculate this and we find the average value. Okay. Okay, now let's look at an example how to calculate this 3-point or expected value for software size based on problem-based estimation. So let's say we have the information of the functions. Okay, for example, here we have user interface and control facilities, 2-dimensional geometric analysis, we have 3-dimensional geometric analysis, and we have the respective estimated line of code. For example, the first one we have 2300 and so on. Okay, now let's say we want to calculate the 3-dimensional geometric analysis. Okay, we want to calculate or to estimate the line of code for the 3DGA function. Okay, so we are given the assumptions that the optimistic estimate is 4600 line of code, most likely is 6900 line of code, and the pessimistic is 8600 line of code. So we put it in the formula. Okay, the optimistic is 4600, most likely 4 multiplied by the 6900, and also pessimistic 8600 line of code, and we divide by 6. Okay, so we get 6800 line of code. So that is the estimate for line of code for the function. So based on this, okay, we further calculate the cost per line of code, and then the estimated project cost, and also the estimated effort. Okay, so the formula is given in the rectangle here. Okay, now let's say we want to calculate the cost per line of code. So it's cost per line of code. So let's say based on the experience, the average productivity for systems of this type is 620 line of code per month, and the burden labor rate is 8,000 per month. Okay, so we use the first formula, labor rate, that means 8,000 per month, divide by 620, that means we get around 12.9, where we round it up into $13. Okay, so that is the cost per line of code.